Thank you, Miriam and Marco. So now, just both of them have also did not specify, but what Miriam did, in fact, was run the model of biome for us, so we could get data to feed in. And Marco helped a lot in the design, the parameterization of INVEST. And also we used data on managed pollinators in the INVEST pollination model, in fact. So, well, I just specify because it won't be seen after, specifically. So, back to the model. So now we could, so you saw two of the models we've been using within it. But so overall, what the model provides as results. So the first thing it does is model land cover changes given some demands for different land covers. So here what you can see is the predicted urban expansion within the municipality around the municipality of Luxembourg City, capital of the country. And the demands we are modeling here are the demands that are specified in the sectoral land management plans defined by the government. So Luxembourg overall is going to know very large scale changes, is supposed to know very large scale changes in the future with almost a doubling of the population and an expected growth of urban areas of almost 20% in some areas. So here what we can see is that the model is predicting somehow where the expansion of different land covers can happen. So here I show you urban, but it also works for cropland or grassland, forests, infrastructure and industrial areas. And it's also it's modeling in place of which other existing land cover changes occur. So it's going to depend, given different factors, it's going to try to rule out if urban expansion is rather going to happen on grassland or forest or other type of areas. So what it gives, so the first result we get of the model is this land cover changes maps. And then these are fed within the ecosystem model we saw before, so biome and INVEST. So here I'm going to show you biome, enter. And I'm going to show you INVEST, sorry. And here so we can see the relative change in pollinator abundance, so what Marco showed in the beginning. And we can see that, of course, it somehow follows the pattern of expansion, but we can see it can have different impacts. I mean, the change differs across location because we won't have the same type of land cover changes all along. So in some areas, you're going to have a different impact on abundance if you replace, if you expand over grassland or forest or cropland. And then this abundance then, it translated into impacts in terms of orchards yield. So here we look at apple orchards, and here each dot is representing an orchard in Luxembourg, and we can see that, again, you have very different impacts depending on where the different urban expansion happen. So, yeah, in the end, we can get these different maps that give us, we get all these series of maps that give us land cover changes and ecosystem service values, and we get them for different services and different land covers. And so then, to fill the objective of values, what we do is we translate this model into characterization factors. So here behind that, there is a methodology we've been working on for a while now, and we are going to submit very soon. But so here I will go quickly, just to tell you that basically we tell the model as, let's say, an overall equation, where ultimately we model land as a function of different land demands and ecosystem services as a function of land. And so characterization factors, to calculate them, we take a marginal approach, and we try to look at a given time, a moment in time, instant in time. We look at how ecosystem services can vary with the change in the land demands, given that the land demands is what we obtain from a life cycle inventory. So it's about understanding how expanding cropland can affect pollination, for instance. And in developing these factors, we take two approaches. We take, let's say, a standard approach, that is to evaluate this change as of now, today. I mean, the latest data we get. And a scenario-based approach, where we are going to look at how this change impacts, how, for instance, cropland expansion is going to impact pollination within the broader large-scale change of what we take here as a reference scenario, that is a sectorial management plan of Luxembourg that has an horizon to around 2032. I mean, it was done in 2012 and it was for 20 years. But it's still debated now, in fact, I think. Anyway. So, what we see, so here I'm showing you, so one more thing is that this model, we apply it at the level of each municipality in Luxembourg. So we can get for each municipality the impact of potential expansion of different land covers. So here I'm showing you partial results over Luxembourg. I'm only showing them for two reasons. The first one is this has not been published yet, so it would be a bit, let's say, optimistic to say we are everything right now. And also because that's where, first, it covers main location of apple hotspots, as we could see earlier in the map of Marco. And also that's where the model behaves, let's say, well and as expected somehow. So on the left, you can see that, for instance, the change in pollinator abundance can vary very largely. So here we look at the impact of urban expansion. And we can see that depending on municipalities, we can get quite sensible variations. Oh. And this then later also has an impact we see per municipality on the production of apples. And one thing that's interesting to see here, so if we look at the municipalities in the circle, is that we can see we have nonlinearities along the ecosystem services provision cascade. So what it means is you can see on the left, pollinators are mostly, have urban land has the largest impact on pollinators in the right municipality, but in fact it has almost no impact on apple production within this municipality. And that's mostly due to the way apple orchards, urban areas are located in space. And what we can see is that behind that is that in the right municipality, orchards are quite further from the urban center than in the left municipality. And so that's why we see that potential small change on pollination smaller change on pollination can have a larger change in apple value. And so that's really something interesting to take into account, the whole cascade chain, cause-effect chain along the provision of services. And that was really one of the main objectives also of values of having multifunctional models and consider these dependencies among landscapes. So here that's the first results we got, these characterization factors as a municipal scale. But then in a life cycle assessment, you would tend not to know at such a high resolution where your land uses occur. You would rather know in which country, for instance, they are going to occur. So what we did then is we aggregated this. And so what we can see here is when we aggregate over all municipalities, we can really get as characterization factors some vector that represents the potential trade-off among ecosystems. So here we look at ecosystem functions, pollination, apple, crop, carbon sequestration, and animal husbandry. And we really see different trade-offs among different land cover types, given that urban industry and infrastructure, so in general, might induce losses in the provision of ecosystems, in the production of ecosystems, which is, let's say, quite trivial. But for instance, here it's interesting to see that industry has a potentially very high impact on pollination and apple production. And that's something we explain, if we compare to urban, for instance, that's something we explain to the fact that industry are in the outskirts of cities where orchards also are. So the expansion of existing industrial sites can be potentially very damageable to pollinators. And if we look the expansion of more natural land covers, we see that first they provide benefits quite logically, and so far that's something that was not considered in LCA methodologies, the beneficial aspect of certain expansion. So by default, of course, if we expand cropland is to gain crops, but it's still an information to consider to really see, in fact, the overall trade-off of this expansion. And here we can see that forest is overall very beneficial in terms of what we would consider regulating services, pollination, and carbon sequestration, while grassland and cropland are large, important providers of provisioning services, crop and meat, but can have potentially high impact on regulating services, notably cropland, that can be damageable to CO2. So, yeah, that's overall. So, and here just also we see two types of factors. So we see the ones we calculated as of now, and the one we calculated according to Luxembourg sectoral plans. And we can see that the impact is not so much varying, but still we see some slight differences, and it's interesting also to understand, let's say, the robustness of the impact we predict as of now. Is it still going to be the same in the future, potentially? And here we see that, yes, so it makes the results quite reliable to consider these different scenarios. And also, later on, Benedetto will show how they apply, kind of how it can provide also interesting complementary results to current practices in LCA. So these are the factors we get for ecosystem functions, but we also develop factors for ecosystem services once valued. So here, impacts are normalized, but behind are quantities, material quantities. So it's apple yields in tons, crop yields in tons, sequestration in tons. I mean, everything is in, not the cows are not in tons. But and so here we see now the impact on the value of ecosystem services. So we conducted some monetary valuation through either for climate regulation, it's a carbon value. And for apple, crop, and meat values are producer prices in Luxembourg. And so here what we see the opposite of the previous figures. That is, we look how each service is impacted by different land covers. And we can see that, for instance, apple is mostly impacted by industry and infrastructure and improved by forest. And, well, then the results are kind of similar to the previous one we saw. But here it's interesting to see also which one are mostly damaged. So crop production is going to be tricky to maintain in Luxembourg. And in fact, it's something that has been observed in the last decades when you look at data that crop areas are diminishing somehow in Luxembourg. And so, yeah, so that's overall the factors we develop at the national scale for Luxembourg. And so in the idea, then it's an effort to be replicated. So here I've not been talking about the model, the practical development of the model, but we can come back to this in the questions. But behind that, we also try to develop the model so it can be replicated in other locations, other countries. So that's the results we get for Luxembourg. And then on the global scale, quickly I think, no? Because so let's pass that then. That's ideally what we wanted to model. So we want to look at how land cover changes affect land covers, affect the provision of services, and in return, how this provision of services affects people and how people react. But so role of Bowman's showed many already examples of things we want to consider, how to consider that in different levels. And so just for the global scale, what we did, so we started from the global version of MIMES, and at the heart of it, there is what you would call a Cobb-Douglas production function. And okay, we can go into the detail of that later in the questions, but the point of this production function is that considering the contribution of built capital, labor, and ecosystems in parallel in the production of different economic sectors of different countries, we can understand how land is a limiting factor to economic development, and how economic development then can occurs within the biophysical boundaries of the globe. And given we have a country scale, I mean, we look at that at the country scale, how the land use per country affects potentially their production. And so when we apply this production function, so what we do, in fact, is calibrate it over past periods. So we see first that it works quite well because the lines you see here are the observed production of the sectors, and the dots are what we plotted. So we can see that in most cases, the production is working quite well. We have maybe Japan that's not so good, USA. We also did that on Luxembourg, but Luxembourg was quite tricky to understand because I guess mostly it's very small. So the land data we got were not very precise, and it's very small volumes, so it's harder to understand. But overall, we see it kind of works. And what's interesting here behind is we can see that land. So here we plot the coefficients we find in this production function. And so this coefficient has to be understood as the higher it is, the higher changes in land use contribute to changes in the production of so here we look at agricultural production, how changes in land use affect, influence changes in production. And so if you think it is the other way, the lower it is, it means agricultural production has changed, mostly it increased, without an increase in land use. So somehow it's something you can relate to the idea of intensification. So we can see that, for instance, in Europe or US, where there has mostly been intensification more than cropping areas expansion, this parameter is very low. While in Mexico and Brazil, for instance, we see it's higher, and that's locations where there have been some expansion. So far it's some first results, and we still need to better understand them, to further analyze them. Also, you can see we cover a large area of the globe, but now here is just samples of the results again, and we are going to extend. Also about that is just, it's really hard to go with all countries because we use input-output data, and usually they're not available for regions like Africa. Africa is taken as a whole. So that's, of course, a huge limit in the development of these global approaches. And so when we take that, just what is interesting then, once we have made what is useful to us, once we have made this model and calibrated this function, is that we can understand the change in economic value due to change in land uses. And if we consider, if we kind of expand the rationale, we can consider that this change is mostly ecosystem services, because that's mainly what land use provides to us and to economic development. So here in the sectors that are concerned by land, we look at agriculture, forestry, and tourism. So it's interesting, for example, that you see protected forest has a very high value in some countries, and that's because tourism has been relying on the quality of these ecosystems. Still, here we have variation in the value per hectare of potential services that goes from even some hundreds to 60,000. So it's in tens of thousands of dollars per hectare to 60,000. So 60,000 is a quite high estimate. So here I just reduce enter to the ones that are kind of remove the outliers. But we still have many land uses that are valued around the $5,000 per hectare. And that's in fact close to results found in other studies, but that did not take at all the same valuation approach. So that's also interesting to see that this approach provides results that correspond to other studies. And so here we can see, for instance, that protected forests have a very high value in general compared to other services. And I'm not going to go into detail. We can go after if you want. But again, we can see different trade-offs per country and per land uses. And we can see differences in values also per country, which is quite interesting, considering the broader idea of applying that over a whole life cycle and of land uses spread around the globe. So, yeah, So as a conclusion, if we consider what we reviewed initially in the project, we see that we did manage somehow to make to develop factors at different scales that are based on a dynamic and integrated approach. And thanks to that, we can make regionalized factors, which are both in material and monetary terms. And it's potentially useful information to identify impacts on from different land uses. And if we consider the, let's say, potential improvements of the model, the main ones would be to increase the granularity of land cover types in Luxembourg. For now, we don't really distinguish different crops. So, so it limits some aspects of the model. Also, we could expand the list of services. In fact, we consider more than I showed you. When we will publish factors on the website of values, there will be more. In the global model, we would like to expand it to consider also how changes in production can affect land cover changes. Now we see the other way around. And finally, there's a lot of work to be done on confirming and assessing the uncertainty of the factors, something we are going to see right after. And a last thing, which Benedetto will also quickly deal with, is how to make them operational in practical LCA approaches. So, yeah, thank you. And if you have questions.
To avoid running out of time, maybe you have just one quick question and you can yes, please.
Just a small question. Could you go to the previous slide?
The previous one?
I want to know which factors you want to use.
How do we go back? Not enter. Sorry.
I want to know which kind of data you will use if you want to do land change modeling at the global scale.
What do you mean? What would we use? So now we started. I mean, we tried it, but the results are not yet good enough. Sorry. We use basically we try to calibrate the model on pace data, and we try to identify different drivers. So we look at population, temperature, economic production, and population growth. And that's the main factors we try to understand on how they influence this. So then, but then it all depends on the objectives you have. There are global model land cover changes, but they all differ very much in the type of land cover they consider, the data and everything. So,
I mean, also to consider the high complexity and uncertainty that is behind this kind of modeling approaches. It's not that easy to address.
No, because you mentioned land change modeling at the global scale. Since in Europe it is current land cover, this is what you are using, I think.
Yeah.
Maybe in Africa and US they have another system. So maybe they have.
Okay. You mean this type of yeah.
And how you do that at the global scale? It's not
But at the global scale, the only you have, okay, if you want, let's say harmonious classification, you have a global land cover, which is the kind of the only one with FAO data too that has this time series, but at the national scale. So if we go with doing land cover changes at the global scale, in our case, we will look just the share of land covers at the national scale. So we won't be using it, doing it over a grid like we did for Luxembourg. But there have been some models that did a grid on the global scale, but they usually use very coarse resolution, so they aggregate different sources of data. So that would be mainly the solution, in fact, to aggregate to 5-6 land cover types. I mean, if you can do it for 5 land cover types, it's already quite good achievement, I think, so given what you do.